This is one of a series of lectures produced by the Further Mathematics Support Programme for A-Level Maths Revision. In this particular video I'm looking at AQA Mechanics 3 specification, and it is question 3 from the June 2011 paper. Well, the question says that we have a golf ball which is hit from a point O on a horizontal golf course with a velocity of 40 meters per second, and the angle of elevation is given as theta. During the flight, the horizontal and upward vertical distances of the golf ball are to be represented by x and y respectively, so standard xy Cartesian plane. We have to show that the equation, the trajectory of the golf ball, is given by the equation x squared tan squared theta minus 320x tan theta plus x squared plus 320y equal to 0. Once we've done that, we're told that the golf ball hits the top of a tree, which is a vertical height of 8 meters and a horizontal distance of 150 meters from where it was hit. So we need to find the two possible values of theta from that. And it says which value of theta gives the shortest possible time for the golf ball to travel from O to the top of the tree, and then give a reason for that. Well, in the first part of the question then, we have the ball which is hit at 40 meters per second at an angle of theta. So this is fairly standard sort of bookwork, as it were, that you need to know. So if we look firstly at the vertical direction and use the equation S equals ut plus a half a t squared vertically, then the position at some time t, the vertical position is y, so that is equal to the vertical component of the initial velocity, so that's 40 sine theta, so this will be the opposite side of the triangle here. So y equals 40 sine theta multiplied by t, and then the acceleration we're told is equal to 10 meters per second, so it's going to be negative, of course, it's acting downwards, so negative 1/2 multiplied by 10 multiplied by t squared. So that's the equation for y. If we look at the horizontal direction, this is constant velocity, so that the x value will be equal to the velocity multiplied by time, and the velocity is 40 cosine theta. That will be multiplied by t for x, and therefore t is equal to x divided by 40 cos theta. Now you can see that the equation that we're aiming for, there's no t in that, so the idea is that we now eliminate t from this pair of simultaneous equations we have by substituting t into here for this expression x over 40 cos theta. So therefore we get that y is equal to 40 sine theta multiplied by x over 40 cosine theta, and then minus, well, the half of 10 of course is 5, and then we've got t squared, so that's x over 40 cosine theta all squared. Just rearrange it, well, just sorting that out a little bit, the 40s cancel out, that should be 40 in that expression there, the 40s cancel out, and then we've got sine theta over cos theta, so that's tan theta. So the first part is x tan theta, the second part 5 over 40 squared, that's 5 over 1600, and if you divide we get 320, so this we can express as x squared over 320 and then cos squared theta. Well, we can see in the expression that we're asked to find that we've got 320y, and that's going to be obvious where that comes from. 300 multiplying throughout by 320. So doing that, we get 320y is equal to 320x tan theta, and then minus, we've got x squared over cos squared theta. Now the easiest way to get that is to say that 1 over cos squared is the same as sec squared. So this is x squared sec squared theta, and we can begin to see where these bits are coming from. Now the expression at the top again has only got tan in it. It's tan squared and tangent, and of course we have an expression for sec squared in terms of tan squared. Sec squared theta is equal to 1 plus tan squared theta. So using that, we therefore get that 320y is equal to 320x tan theta, and then minus x squared multiplied by 1 plus tan squared theta. Again, looking at the expression at the top, we can see that the x squared tan squared theta, which is here, is written first, and we're going to have to take that everything across to the left hand side to write it as equal to 0. So doing that, I think we can then say that the final line is x squared tan squared theta. We've then got minus the 320x tan theta, and then finally plus x squared and 320y, and that's equal to 0. So there we are, we've got our final expression that's needed. The marking for that part of the question, there was an A1 mark for getting the expression for y, an M1 mark, and then A1 for substituting for t, and then finally an M1 and final answer mark. Remember that you're given the final answer, so that you need to show your working and how you got there throughout that sort of question. The second part of the question asks us to use some particular values for x and y. The vertical height, this is the y value, equal to 8 meters when the x value is equal to 150 meters. So if you substitute those into the equation we found, then we get that 150 squared tan squared theta minus 320 multiplied by 150 tan theta, then plus 150 squared plus 320 multiplied by 8 is equal to 0. So simply substituting the value we've got. This comes out to be 1125 tan squared theta minus 2400 tan theta plus 1253 equal to 0. That includes, actually, to get to that line, I've also divided through by a value of 20. It's not really strictly necessary to do that, but we've now got a quadratic equation in tan, so that tan theta is equal to minus b, which is 2400, plus or minus square root of b squared, so the 2400 squared minus 4ac, 4 multiplied by 1125 multiplied by 1253, all divided by 2a, so 2 multiplied by 1125. Two values. That actually calculates, if you want to know, to 1.22 or 0.9 912, which gives theta equal to 50.7 degrees or 42.4 degrees. We're asked to say which of these gives us the shortest time. Well, if we go back to the first part of the question, the time is equal to x divided by 40 cosine theta. So we want the value of t, which is the smallest, which means that cos theta has got to be the greatest. And cosine 42.4 degrees is greater than cosine 50.7 degrees, so that means that the minimum time is given by the smaller angle. Theta is equal to 42.4 degrees. The marking for these two parts of the question, then there was simply a M1, A1 for getting the correct equation here, and then M1 and 2A marks for the values of theta. And for the final part, a mark for explaining and then a B mark for getting the correct value. Well, that completes that question. You'll find other information and links to other videos at www.furthermaths.org.uk.